Think of the OSI model as a 7-layer cake. It's fantastic for teaching and understanding the basics. But when you step into the real world of the internet, you're dealing with the TCP IP model, which is more like a 4-layer sandwich. It's practical and gets the job done. For the CCNA exam, you've got to get comfortable with both models and how they fit together, because that's where the magic happens. The TCP IP model is composed of 4 layers. At the very top, we've got the application layer. This is the playground for protocols like HTTP, DNS, and SMTP. Anytime you're interacting directly with a protocol, it's happening here. Dropping down a level, we enter the transport layer. Imagine this as your trusty delivery service. TCP is like a careful courier making sure every package reaches its destination safely, while UDP is more like sending a postcard. Quick, but with no guarantee it'll get there. Then there's the internet layer, home to IP, ICMP, and ARP. This is all about logical addressing and finding the best routes, kind of like the postal system, figuring out the most efficient roads to send mail. Finally, we land on the network access layer. This is where the rubber meets the road, handling all those physical connections and data link functions. Think of it like the combination of Ethernet, Wi-Fi, and those reliable MAC addresses all working together to keep the data flowing. Picture TCP/IP and OSI as 2 different ways to organize a networking dinner party. TCP/IP has 4 main jobs: managing the guest list, serving the food, finding the dining room, and setting the table. Here's how it lines up. The application layer in TCP/IP bundles OSI layers 5, 6, and 7 into one big role, covering everything from sending the invites to keeping the party chatter going. The transport layer takes care of OSI's layer 4, making sure everyone's dinner gets to the right spot. The internet layer, which matches OSI's layer 3, is all about guiding guests to the party room. And network access combines layers 1 and 2 of OSI, focusing on the logistics of setting up tables and chairs. Now, the OSI model is more like a formal banquet, with roles like presentation for encoding and encryption, and session for managing the flow of conversation. In reality, though, protocols can mix things up, like a party where everyone helps out regardless of their assigned duties. Confusing? Yeah, it can be, but like navigating a jam-packed intersection on a bike, it starts to click after a few tries. Think of sending a letter through the postal system. Every step in the process adds its own envelope or stamp. First, the application layer crafts the content of your letter. Then the transport layer steps in, adding a TCP or UDP header, and voila, you've got a segment. Next up, the internet layer slaps on an IP header, turning it into a packet. The network access layer goes last, wrapping everything with an Ethernet header and trailer, creating a frame. Once that's done, the frame gets broken down into bits, and off it goes. When it lands at its destination, the process reverses. Each layer peels away its packaging as it climbs back up the stack. This unwrapping is called de-encapsulation. It's a bit like peeling an onion, layer by layer, until you get to the core. Let's break down the TCP/IP model, where each layer has its own set of protocols ready to shine. At the top, the application layer hosts a lively bunch. You've got HTTP and HTTPS running the web show, DNS translating website names into IP addresses, and DHCP doling out IP addresses like a maitre d' handing out table numbers. For moving files, there's FTP and TFTP. For sending emails, you have SMTP. Looking after network management is SNMP, while SSH provides secure remote access. Then there's Telnet, not as secure but still handy for certain remote jobs. Slide down to the transport layer, and it's like picking between a comfy first-class seat and a quick economy trip. TCP is your reliable travel companion, making sure all data arrives in the correct order, like a meticulous event planner. UDP, on the other hand, is all about speed, less worried about order, more focused on getting there fast. In the internet layer, the real workhorses come into play. You've got IPv4 and its shiny new upgrade, IPv6, directing traffic to the right place. ICMP acts as the troubleshooter, pinpointing issues along the way, while ARP is the trusty old phone book, pairing IP addresses with the right MAC addresses. Finally, at the network access layer, we're getting into the nitty-gritty of data transmission. Ethernet's your wired option, while 802.11 covers the wireless realm. Think of this layer as the roads and highways that ensure your data gets from point A to point B. All right, let's dive into those sneaky exam traps that lurk around TCP/IP and the OSI model. First thing to keep in mind, the TCP/IP model has 4 layers, not 5. Sometimes you'll see a 5th physical layer tacked on, but that's not in the original RFC 1122. Stick with 4. Next up, ARP is a bit of a chameleon. In the TCP/IP model, it hangs out at the internet layer, but in the OSI model, it stretches across both layer 2 and layer 3. For ICMP, don't let it trip you up. It belongs in the internet layer, not the transport layer. When you're tackling those CCNA questions, they'll drill your OSI layer numbers into you, so have layers 1 through 7 down pat. Lastly, remember TCP/IP was the trailblazer, predating OSI, which serves more as our theoretical playbook. That wraps up our dive into the TCP/IP model. We've navigated through its 4 layers, compared it to the OSI model, talked about encapsulation, and sorted out which protocols belong where. Feeling ready to tackle some questions and lock in what you've learned? Head to Courseiva.com for hundreds of CCNA practice questions. You've got this in the bag.